Okay, so we're going to go ahead and continue on. We will start with a piecewise defined function. So let's go to page 17. Example number 5, graph the following. So we have f of x, which is defined as negative x when x is what? Less than 0, and it's x squared when x is between 0 and 1. And then I have, it's equal to also, and then 1 when x is greater than 1, okay? So this is the function. The function is defined in pieces. Hence, it's called a piecewise function. Okay, so when x is less than 0, so y is equal to negative x. So when x is less than 0, the function is y is equal to negative x. The line y is equal to negative x, right? Between x is 0, but actually it would be an open circle here because that x, the 0 is not included. The 0 gets included here. When x is equal to 0, it is this. But the value is the same as here. So it gets filled in. And then I have here, and also here, to 1. When x is equal to 1, y is equal to 1 because it's x squared, right? X is equal to 1. 1 squared is 1. Okay, so here we go. When x is greater than 1, the value is 1. So when x is greater than 1, I go like that. So that would be my piecewise function. It is defined in pieces, so it's a piecewise function. Okay? That's how it would look. Example number 6 would be the kind of the other way around. Write a formula for the function when the graph consists of 2 line segments in figure 1.16, which is on page 18. If you look at page 18, that is what the graph is going to look like. So they're giving us the graph, and now we have to write the function. So the graph looks like that. 1, 1. Open dot there, close dot. Close dot, 2, and again 1. So this is 2 and 1. So the function is defined as what? Okay. Is the function defined over on this side? Is there anything there? There's nothing there, right? So there's nothing there, so don't even worry about it. Between here and here, the function is this guy. What is this line? What is the function? What is the line here? This is y is equal to x, right? So y is going to be equal to x when x is between 0 and 1. So when x is between 0 and 1, it's going to look like that, right? When x is between 1 and 2, the function looks like this. So normally it would come all the way down and meet here at -1, right? If I stretch this out, it would look like this, right? But this is not here. But the line looks like this. So it's going to be what? Y is equal to x minus 1. That would be the function here, right? That would be the function between 1 and 2. So 1 and 2. And that would be your answer. Okay? And yeah, that's it. All right, so here, see how that worked? We made sure that when we did the first one, it goes all the way up to here, but here is an open dot, so 1 does not get included in there. 1 gets included here, down here. This is where the 1 value is. It goes like that, and that's going to look like that. Okay, absolute value function, the absolute value function. Okay, we did a little bit of this last year. y is equal to the absolute value of x. And this, if you remember correctly, looked like that. So this is y is equal to x like that, because this is actually, when x is greater than 0, it is x. When x is less than or equal to 0, it's negative x. Okay. Question here as well, Mr. Ron, you put the negative here, the equals over here in the negative part instead of the positive part. Does it really matter? It doesn't really matter, right? Because I can go like this. It still doesn't matter because when x is equal to 0, either way, it's still going to be 0, right? Whether it's plus or minus, it doesn't really matter. Okay, all right. So this is what the graph looks like. Now we can also move this around, right? We can move this point around. If I were to translate this point and bring it down like this, where it goes through the point plus 2 and negative 2, how did that translation work? I took this graph and I translated in the x direction, which way, how much? Can anybody tell me? I took this guy and moved it to 2, right? So this, instead of x, what do I get here? I'm going to put x minus 2. Then I move it down 2. So instead of y, it's going to be y plus 2, right? It's going to look like that. That's my translation. So the end result is that. Okay, are we good there? All right. So we can do that. Composite functions. We did this also last year. Composite functions. This is the f dot g stuff. F dot g. So if I have function f is equal to x squared and function g of x is equal to sine x, f dot g is equal to what? F dot g is equal to wherever x is in the f, I'm going to put this function into the x. So it's actually going to be f of g of x. So g of x is the sine x. So this is the same as sine x. So wherever x is, I'm going to put sine x. So it's going to be sine x squared, right? So where x is here, I'm going to put the sine x in there. So it's the same as sine squared x. Okay. What is g dot f here? G dot f would be g f of x, like that. So an f of x is equal to x squared, right? So this would be the same as g of x squared. So x squared, I'm going to put that in there. This is the same as sine of x squared, right? This and this, notice, are totally different things. Okay? Because this is basically the sine of x squared, where this is the square of sine x. Okay? So f dot g and g dot f are not going to be the same, okay, for the most part. Sometimes they are, but most of the part they aren't, okay? And as long as we're talking about composite functions, another thing we talked about is this being 1 sometimes, okay? If it's 1, no, I mean if it's x, right? We'll talk about it later on. Don't worry about it. It'll come up later. Okay, so example number 8. Example number 8. Find a formula for if g of x is equal to x squared and f of x is equal to x minus 7. Find the following. So in this one, we have f of x is equal to x minus 7. G of x is equal to x squared. By the way, this is example 8. So we're looking for what? F dot G2. So we want to find F G2 like that. Okay. So we do this. We do this. G of x is what? G of x is this guy, so it's x squared. So where x is, I'm going to put x squared, so it's going to be x squared minus 7. Because where x is, I'm going to put x squared, so it just goes in like that. But here we want to know the value for 2. So when it's 2, I get 2 squared minus 7 minus 3. Okay, so that's the answer. All right. Are there any questions on what we talked about today? Does anybody have any questions that we can talk about? All right. No questions. All right.